name is Adeyanju Micheal. I am a security engineer. Sometimes you call me a penetration tester. At the same time, you can also call me an ethical hacker, basically. So I have years of experience working on series of APIs and APIs that cut across different industries, aviation, edtech, and fintech, like the common one that we know. All right. Today I'll be talking about building resilient APIs. So today I'll be talking about building resilient APIs, strategies that helps in handling API attacks. Now, the question we need to ask ourselves, or the question we need to answer now is, why are API targets? Like I said initially, we use them in our day-to-day lives. And you agree with me that it has gotten to a stage in technology where things are very much easy, right? It is very easy for you to carry out a transaction from the comfort of your home. It is very easy for you to literally do anything from the comfort of your home, right? Now, with more functionality or with more ease comes with more vulnerability. That is what a pen tester will tell you. The more easier it is for you to live your digital life, the more we have a threat surface that anyone can take an advantage of, right? So APIs attacks have increased dramatically, and from reports, we're able to know that we have over 83% of web traffic that involves APIs currently. Now let's talk about the API threat landscape. But before we talk about the API threat landscape, we need to ask ourselves, what is an API? Now, before we dive into the threat, essentially, we need to understand that APIs are a set of rules you give a software to communicate with another software, basically, in a layman term. And we have different types of APIs. We have the RESTful APIs, we have the SOAP APIs, we have the GraphQL API. And one thing that is very common with all of these APIs is they have their strengths and they have their weaknesses, which is most likely going to be exploitable by anyone at any point in time. So that the fact that you are not using a particular type of API does not mean your system is prone to being hacked or your API is prone to being hacked. Now let's talk about common API attacks. I want to believe that most of us here are developers or we are into the digital space, basically. Now, the first common attack that is common to an API is an injection attack. An injection attack is when an attacker inserts malicious inputs, SQL or no SQL, that get executed by the system. And this can lead to a data leak, modification, or system compromise. Now, there's a thing with API when it comes to injection attack. Injection attack might not necessarily be executable, but the moment your system or your API allows unsanitized inputs, it is considered to be injection as well. Now, one other common attack that we have is broken object level authorization, right? This is a case where the attack occurs when an API does not properly enforce authorization checks for each object. And when we are talking about objects, we are talking about users within the system. That is the way the system sees them. It sees them as an object. Attacker may exploit this to access other user data by manipulating the object ID. This is a very common vulnerability where, let's say, for example, you built your application and you logged into your application. There is an ID for each user within your application. Now, the 0 is assigned to the admin, which is the super admin on the system. Then the next person creating the account could be like a regular user. The number goes on sequentially, 1, 2, 3, continuously. I think you understand what I mean. Now, if an attacker is able to manipulate that ID without any proper authentication, that is a broken object level authorization. Now, moving on to the next one, mass assignments. Mass assignment vulnerability occurs when an API binds client inputs to server-side variable automatically. Attacker can exploit this by assigning values to fields that shouldn't have access to, causing privilege escalation or system abuse. Now, I added, this is like a JSON input here, which is admin true. Now, we have cases where, when you want to log in into an API, now I want to believe you understand how we do back-end assessment and all that. So this is not even the front-end thing. Now, when you want to log in into an API, or when you want to access an API part, you have your login credential, which is your username is serving as a payload 1, your password is serving as a payload 2. Now, in this case, mass assignment vulnerability is existing if a particular attacker is able to add an extra parameter, which is, now, if I'm logging in as my name is Michael, and I'm putting in my password, assuming I'm not an admin in that system, mass assignment is allowing me to say, okay, you know what? I will log in as Michael, drop my parameter there, and the moment I say is admin is equals to true, now that is taken into consideration by that API, and it's going to give me what? Admin privilege within the system. I hope you understand. Now, moving on to the next one, cross-site scripting. Now, cross-site scripting is actually common in front-end applications, but now cross-site scripting is a thing we need to pay attention to on APIs too, right? APIs that process and return data to the user interface are vulnerable to XSS, where attackers inject malicious scripts that execute in the user browser. What is there is, we know how we write our JavaScript to alert to us, maybe on a pop-up on our screen. If we're able to make our APIs do that to the front end of our application, it's a problem. That is the basic idea behind cross-site scripting. Now, let's talk about denial of service as well, or rate limit bypass. Now, if attackers are able to overwhelm the API with traffic, exhausting the resources and making the service unavailable. Now, this is a case where attackers are able to send multiple traffic to your system. Now, the moment they're able to do that, your system will shut down and will not be even be able to respond to legitimate requests. So now, let me give you a very good example of that, and I think this is one thing every developer should pay attention to. During the course of you building your application, you might outsource some parts of your APIs to, let's say, other microservices, which is not directly built by the developers. And a very good example of that is the SMS. We know how to plug our applications into SMS API, not we building the SMS part of it, where whenever you try to reset your API, OTP is being sent to the customer, right? Do you understand what I'm saying? So now, denial of service or rate limiting is very possible in that particular endpoint because I keep sending that request, and you did not put any security measure in place that, okay, I can only request for 2 OTPs within 10 minutes. Do you understand what I mean? So if you are not implementing any rate throttling mechanism in place, your API is most likely going to be vulnerable to denial of service or rate limit bypass. Another one is sensitive data exposure. This is very common among the fintech application, a case where the API do not encrypt sensitive information. For example, the personal information, financial records, or implement a proper access control risk exposure. Now, I mentioned something here. I said the login endpoint. Just like I was saying, so let's assume I am using a fintech application and I'm just trying to do like a quality assurance on the API side of things. And I'm logging in with my username and my password. Now, why should that endpoint give me a response that is also showing my BVN? Why should that endpoint also be giving me information that is related to my date of birth? They are not necessary. And even if at all your application needs it, or your API needs it, it needs to be what? Encrypted. Do you understand what I mean? So if I'm logging in into your application, let's say not even through the interface, because all of these things are most likely not going to be seen through the interface. They are seen through the backend, through Postman, whenever we're doing our quality assurance stuff, and we get to see stuff like this. So you seeing sensitive information on a particular endpoint is considered to be sensitive data exposure and could lead to some financial implications for your organizations. Insecure deserialization, a case where an attacker was able to send malicious crafted serialized objects to the API that improperly handles deserialization, leading to remote code execution. There are a lot of technical details to this, and I don't want to go into it now. Now, authentication and authorization issue. Authentication is who you are. Authorization is what you have access to. The moment your application or your API does not have a proper configured authentication and authorization mechanism, then the application is vulnerable to this kind of issue and can lead to unauthorized access to sensitive data as well. Now, we've talked about the common attacks that a particular API can have. Let's talk about the solutions. Key principles of resilient API designs: security by design, least privilege, fail-safe defaults, input validation, and output encoding. Now, we're talking about security by design. Security must be integrated from the API design phase, a practice known as shift left, CI/CD, DevSecOps, development security and operations. That's the basic idea behind shift left security. And this involves assessing security risk and implementing security controls early in development. A proactive approach like threat modeling can help identify potential threats, potential attack vectors, and address them before development phase. If vulnerability is not fixed in a testing phase, it should not move to staging. If it is not fixed in staging, it should not move to production. Right before you are building your application, create a threat model, right? Look at where this API can be vulnerable. You factor that into your process of development. It will make you have a better application or a better API, and that is what we mean by security by design. Least privilege. API should expose only the minimum required functionality. This principle of least privilege reduces the attack surface by limiting what a user or application can do. For example, an API for retrieving data should not allow users to modify or delete it unless it's explicitly necessary. If you are creating your API for, let's say, a banking app, not necessarily a banking app, basically, just for maybe one particular sector of the general thing, and you have an admin, you have a regular user, you have a compliance person. Now, let me use the fintech. You have a compliance person, you have your customer success. Now, these are the stages or level of access anyone can have within your system. Least privileges, you know what? You're a customer success person. If you don't need it, you don't need to see it. You don't need to have it. That's the whole idea behind least privileges. Let's forget about the English. Now, a fail-safe default. A fail-safe default means the system denies access by default and only grants it when explicitly allowed. So if an API encounters an unexpected error, the system should fail safely, ensuring that no sensitive information is leaked or operation continues unsafely. Now, a very good example of information leakage or fail-safe default not properly implemented is, I have a username, I have a password. Now, why should my API response be, my username is invalid? Why should my API response be, my password is invalid? Now, it is giving an attacker an insight into your application that, okay, you know what? Whenever we try to access this particular API, it is going to confirm to us that the username you are providing is not correct. The password you are providing is not correct. Why not just give a generic answer and say, okay, you know what? The credentials you provided is not correct. The attacker will not have an insight into what is even valid on that particular endpoint. Now, moving on to the next one. Input validation and output encoding. I've mentioned output encoding before, where personally identifiable information should be encrypted. If I'm logging in and you need my BVN to show up in the response, let it be encrypted. It shouldn't be what somebody will be able to see. My date of birth should be encrypted. These are personally identifiable information that has to do with output encoding within your API. For input validation, proper input validation is crucial for preventing attacks, such as injection and XSS. Input should be validated based on expected type, rejecting strings when integers are expected. The same way quality assurance is doing a functional test of how an application to accept a particular input, same thing should be done to an API where it does not accept strings where integers are needed, and it does not accept integers where strings are needed. Let's move on, please. All right, authentication and authorization best practices. You can make use of OAuth 2.0 or OpenID Connect. And for OAuth 2.0 and OpenID Connect, they are industry standard for security and API access. And this token-based authentication system allow API consumers to authenticate without sharing credentials and using token for authorization. And I think one other one is API keys and the JWT token, right? Most APIs nowadays implement this second one. So while APIs are widely used, JSON Web Token provides a level of advanced feature. They can include metadata such as your role and what you are assigned to do, ensuring data integrity. Now, for you to confirm this, you can just go to maybe whenever you're doing your quality assurance test on a particular API, you get your JWT token. Now go to jwt.io, input that particular token there, and all of these details, which is your user role, everything related to that particular role who is signing in for you to get that bearer token will be shown on the screen. Also, role-based and attribute-based access control, RBAC and ABAC. Fine-grained access control should be implemented to limit user actions. You should be given what you need, right? For you to prevent this, to like a case where a particular user would have more access than what they need to have, you can just do like an audit. You know who has access to the application. You know what they are using the application for. Now, go through your audit list of users who is using your system and just, you know what? This person is an admin. They need a general access. This person is a customer person. They need access to customer information. They don't need to be able to delete information. They don't need to be able to add customers' information as well. All of these things are things we need to pay attention to while we are building our API. Also, preventing common attacks. I've talked about the common API attacks. Now, for you to prevent injection, use parameterized queries and prepare statements to handle user input safely. Implement strict input validation and avoid dynamically building queries based on user input. If a user is inputting stuff like a code, now let me give you an example of an injection. Like this is what every hacker would know. A code space or 1 equals to 1, semicolon, dash, dash. Now, you see the one I gave you now is just going to give you access to the admin account directly. There are several cases of SQL injection, and some could be error-based for you to know that SQL injection is actually happening in that particular endpoint. Some would not even give you like any value, which is in the case of blind SQL injection. But whenever you are trying to prevent this kind of thing, let's say somebody input a quote. If that entry is not supposed to allow a quote, it should not do what? It should not take it in. Now, even if it should take it in, it should do what? It should be encoded. The moment it is encoded, when it gets to the backend system, it does not see it as that particular input. Now, moving on, prevention against Bola attack, broken object level authorization, ensuring authorized check are applied at every object level request. I mentioned this earlier. If you're a customer on the system, an audit should be done to make sure a customer has access to what a customer access person should see. Avoid exposure of object identifiers in URLs. How do I mean? You know the way you build your application where you see ID equals to 0 at the URL. Maybe you've noticed that when you log into applications, you will see a case of, let's say, ID. You've logged into the application, then you see this question mark, ID equals to a particular parameter. Prevent that from happening within your application. It can happen, but it should be at the back end, right? All right, moving on. Mass assignments. For you to prevent mass assignment, you need to implement a whitelist that explicitly defines which field can be updated through the API calls. Avoid automatically binding user input to object attributes, especially in frameworks that enables this by default. Now, a lot of developers are making use of frameworks. Now, this framework by default is also saving you from security issues, but at the same time, they put you in some security problems. So, for you to prevent mass assignment, just make sure you explicitly define or you have a whitelist of things you want your APIs to accept. Whenever there's an update going on, or maybe, now what I mean by updates is maybe there's a new parameter coming in, like a new set of payloads, username and a password. Make sure that endpoint does not allow just more than the username and the password. If there's any other parameter that should be there, it should be there. If it is not supposed to be there, you should explicitly define on your API that it should not be there. Rate limiting. Now, this is a very common issue on all APIs. It might not be a security risk, but it's a thing you need to look at. Now, how is rate limit an issue? Like I said earlier, SMS. It is very easy for you to implement SMS, maybe probably through some third-party microservices, and you feel like it's not really much. But imagine they are charging you, let's say, 10 naira per SMS token that has been sent to reset a password. And all I just have to do was to automate the process. I can just write a call request to keep calling that particular endpoint multiple times. The organization is losing money, even if it is not much. But I don't think it's something the business people want to know or your C-suite people want to know that, okay, our application is not properly secured and they're losing money based on SMS being sent multiple times. So that's the idea behind rate limiting. Limit the numbers of requests a user can send within a particular time frame. This is also applicable to your login endpoints. The moment if a user is valid, let's say a username is valid, the password is not valid, there should be a lockout mechanism in place. Now, if the username and the password is not valid, there should be an IP address lockout mechanism in place, such that if you keep trying multiple password and wrong username, your system would get a lockout of, let's say, after 5 trials, your system will have a lockout where that IP address will be blocked for, let's say, 10 minutes, 20 minutes. And this will not just prevent you from rate limiting or throttling, it is going to prevent you from brute force attack or credential stuffing. Moving on to the next one, data security in transit and also data security at rest. All API communications must be secured by using a TLS and SSL. There's more details to TLS and SSL. You don't just use anyhow TLS and SSL, because to some levels, they could be decrypted. You make sure you use that to encrypt your data in rest, and for sensitive data stored on servers, implement strong encryption algorithm and follow best practices for data encryption at rest. Now let's talk about some other advanced security measures: API gateways, WAFs, web application firewalls, security logging and monitoring, automated security tests. Now these are things that you need to do to prevent your API from having issues around security. Now for API gateway, an API gateway acts as a central control point for managing API traffic. Everything that goes to your API, everything that your API is sending back, inbound and outbound traffic, should go through your API gateway. Now, API gateway can enforce some policies in place, such as rate limiting, authentication, and login. Popular gateway, we could use AWS API gateways, which offers a built-in security feature for simplifying API protection. Now, if there is a proper gateway in place, that is when you can set it to be, okay, you know what? Whenever there is a wrong username, whenever there is a wrong password, block so IP address for 5 minutes. Now, in a case of credential stuffing, or in a case of brute forcing, where somebody has parameters just to test against your system, they will get locked out for 5 minutes. And let me be very realistic with you. As an attacker or as a threat actor, they don't have that patience. The moment you are disrupting it, they don't really try further. So if you could disrupt that, like, let's say 5 minutes, 10 minutes, and thing keeps going on. Now, the worst case scenario, implement an IP address block for that API. That would be like a roadblocker for them as well. Although, just pray you don't meet someone that is ready to bring down your system, because we don't back off easily. Now, web application firewalls. A WAF can block common API attack patterns, such as SQL injection. Now, the moment you already set a rule, you set a policy that, okay, you know what? If you see an SQL injection pattern, implement a particular type of block. So it monitors incoming traffic and applies rules to filter malicious requests. Deploying a WAF is a quick and effective way to provide additional security layer for your APIs these days. Security logging and monitoring. API traffic must be continuously monitored for anomalies, implement comprehensive logging to capture all API interactions, and use centralized logging such as ELK, Elasticsearch, Kibana, or Splunk to analyze traffic. And also make use of security information and event management tools that can help you to detect and respond to security incidents in real time. So this is an organization that have, let's say, you have your security team, and within your security team, we have the defensive part, we have the attacking part. Now, the defensive part should be responsible for things like this. Implementation of SIEM. It might not be a major team. It might be a thing of maybe a particular expert will be handling it. We call them the SOC, the Security Operations Center Analyst. So they'll be in charge of implementing stuff like this for your organization, and it helps you to notice everything going on your API, such that if something had gone wrong earlier, through an audit review of your log, you'll be able to see it and you'll be able to remediate before things go bad. Now, automated security tests. Tools like OWASP, Bob Suite can help automate the process of testing your APIs for vulnerabilities. And also, regular penetration testing should be done. You could hire a penetration tester, just like me, to do an API security assessment for your application to discover hidden attacks or hidden weakness in your API and help mitigate them before they can be exploited. Like I said earlier, if you find issues in your in the beginning stage of your application, don't let it move on to the next stage and say, we will fix it later. No. The longer it stays, the longer it becomes an issue. I understand that business wants to make money, but at the same time, it is going to cost you a lot at the long run. Also, handling API rate limiting and denial of service. I think I've talked about this. Preventing overload, right? Employ rate limiting techniques. Burst limits allows for temporary traffic spike, but sustain a high rate of requests that should trigger a throttling mechanism. Just put a policy in place on your WAF. Put a policy that, okay, you know what? The moment a request is coming from this particular server to my system at a particular speed, just implement a block. IP whitelisting and blacklisting. If there are critical endpoints on your APIs, because there are some APIs that there is a level of authorization you need to have before you can access some endpoints, you can put a whitelist. Now, whitelisting is just, okay, you know what? This IP address will be able to have access to this endpoint. And that should be like an internal thing. Or maybe you built your API and you want partners to be able to use them. So you now ask, let's say it's going on between bank A and bank B. Now, if they want to consume that particular API, ask them the IP address of their system. Because that particular endpoint is what? Is very critical. It might be for a resetting password of like business partners and all of that. So it's very important we know about IP whitelisting and blacklisting. Blacklisting is you are putting it on a list and those blacklists is just, it's a block. Circuit breaker pattern. A circuit breaker pattern prevents cascading failure across interconnected systems. If one system becomes unavailable, the circuit breaker detects the issue and temporarily blocks the request to avoid overwhelming dependence. So if there's an issue, just like a circuit breaker, when there's like fluctuation in light and all that, it trips off itself. So that's just the same system or pattern you can implement on your API. Now, several case studies of API security implementation, we have the Twitter API rate limiting, where they allow only a set of numbers of requests to be set by a particular user, and it prevents API abuse while ensuring high-quality user experience. Also, Facebook Graph API security, where it's a security breach that happened where millions of users were affected, and this highlights a very good importance of access control, and the failure to properly enforce token validation led to unauthorized access to the system, demonstrating the need for ongoing security assessment as well. You need to keep doing security assessment. Your system can never be 100% secure. 100% security is a myth. The banking system knows it. Any system anywhere knows it. There is nothing like 100% system being secured. Just pray you don't have your time. Now, best practices for API security, we call it the SMART. Secure API endpoints. Monitor the traffic. Authorize correctly. Regular audits. You can put me on standby for your APIs. If you just call me in the middle of the night, anytime, any day, you want to do a regular audit. Test continuously. Your quality assurance team, make sure they are technically inclined, security inclined, such that whenever they are doing functional tests, they still look at the perspective of an hacker. They can be an hacker, but they should be security aware as well. All right, I think that's it. Please, do you have any question for me? This is a Q&A time. How could Bob sit up with testing of weaknesses in API? Let me be realistic with you. Now, we said you should use OWASP app and Bob Suites. Now, you need to understand something, which is those tools can give you a false positive. Now, what do I mean by false positive? They won't give you the best answers at the time if you don't know what you're really doing. Somebody can train you to use Bob Suites, but at the end of the day, it might give you results that you might not really like, might be a fake result. So now, using Bob Suite is good, but at the same time, it cannot be as someone who is doing a manual test for you. Do you understand what I mean? And there are some configurations that you can put in place, even if you want to automate it. Most times, what we are saying you should scan, or what you are saying you should audit should be like a base URL, which is the base URL that endpoint is consuming. Do you understand?
So thank you very much for your presentation. It's very informative and incisive. So what I want to ask concerning the security that has to do with authentication. So your use case where you mentioned here in your presentation is the use of password and email, for example. And you talked about um, responding with a generic message to the user instead of specifying that specific field or credentials that is invalid. For example, if a user is trying to log in to their account and then let's say they did a typo in their username but they provided the correct password and then it just gets an error message like credentials is invalid, for example. And from what you say, it's like that's more security inclined because it does not give attacker this idea that, oh, the username is correct and then they keep trying alternative passwords. So, but looking at it from a user experience perspective, myself as a developer, while building APIs, I try as much as possible to make individual fields like specific to know what particular error is, what particular credential is invalid, for example. Let's say you provide a username, I query the database and check if that username exists, and then I tell you username is invalid. And if you provide the correct username, and on the other hand, you provide a wrong password, I'm just going to say the password is incorrect. So I also want to get, like, you are talking from someone that's a security inclined person, and then I'm talking from a developer perspective, thinking of user experience. So what do you think is more security wise, and should we just go with security and then avoid or ignore the user experience?
Yeah, thank you very much. I understand your question perfectly. There is a thin line between functionality and implementing security. But for what you are saying in particular, instead of you having an endpoint tell you a username is correct, or no, a password is incorrect, are you focusing on your business or you're focusing on the way attackers will see your customer? Fine, I'm not saying you shouldn't focus on your customers, but what if you get hacked? Or what if that particular endpoint is being like tried multiple times? Because if I, as an attacker, come to your system and I send, let's say, a username and a password, and your system is validating to me that that username is correct, but the password is not wrong, what do I have to do? I'll go to Bob Suite, like I said, and I will select, now I will get the parameter to come in. The request, I will intercept the request, send the request to the intruder part of Bob Suite, for those of us that know Bob Suite. Then I will now select my parameters. I know the username payload is correct. The password is the one I want to deal with. And I select a group of passwords from somewhere, word list, we call them word lists, and I start using them against your system. Luckily, your system might not even integrate API throttling as well, and it becomes a problem. Do you understand? So it's risky. You want to prioritize customers for customer usability or customer experience, and you also want to prioritize security. But if one customer is complaining about why certain things are not working, you can easily explain to that person it is because of your what? Of your own data. But you now saying because one customer is complaining, if at worst, if customers are complaining, you can actually have a session for them to enlighten. No, that's what you can do. You can have a session to enlighten them than attackers coming for your system and finding out you don't have that kind of implementation in place. Oh, wow. I hope you guys saw this, my Twitter, so probably you can drop those questions there. I still have about 5 minutes left, so I might not take all the questions. Are you raising your hand? Okay, I feel like it's easier. Okay.
Hello.
You go next.
Sorry, can you hear me?
I thought you had the one speaking. Oh, someone has the mic there. Okay. You go next then.
Okay. So thank you. You did a very impressive work. I have to commend you for that. So I have 3 questions.
Three questions.
Okay, let me take 2.
You have how many questions?
3. What's 3?
One question. Three. Can you give one to give space for others?
All right, thanks. So, how do you ensure your API design is adaptable to future changes and evolving requirements?
Come again.
Okay. How do you ensure your API design is adaptable to future changes and evolving requirements?
How do I ensure the API design is secure and what? Is adaptable to future changes? We have continuous integration, continuous deployment. So now, I want to believe those changes are based on customers' requests or based on the company trying to grow from doing more than one thing to other things. Now, this is the thing. It might not be easy to make some new implementation. It is general. I think it happens across every other organization where you are trying to move to a particular part and they are just like changes that if you make them at that time, everything will scatter. Developers can relate to this. So what you do is you just factor it in. You have to just factor it in. Now, even if you're implementing those changes, just look at the security issue around those new changes you are implementing. Now, I've seen a solution that was built on, I think was built on a particular version of Next.js, and the developer came in and had to like change the entire thing. You understand? It took a lot of work anyways, but it was achievable. It was a lot of work on developers and security guys are like police and thieves. The next person is here. Oh. I have about 2 minutes left. Just last one question. Yeah. No, yeah.
My question is with respect to penetration testing.
Okay.
Yes, I work with a company where we outsource a particular software from another. Now, our NGX mandates that we do penetration testing every 6 months. No, 3 months.
Quarterly.
Now, sir?
I said quarterly.
Yes, that will do it. Now, my question is, why do we even need to do it as in from our end? Necessarily because we're not the one that developed the software, and we're just users. We're just using it according to our customers, like the same software. So what's the need for the test on our end? Why is it essential?
The reason is because you can never be too sure that your application is secure. That's like the basic answer. You can never be too sure. I can tell you for free, your application is not 100% safe. Anybody, like I don't even know any biggest firm anywhere would not tell you that system is 100%. It is. Why would you even say that statement? It's even attracting attackers already for you to utter that kind of statement. Anyways, thank you for having me. My name is Adeyanju Micheal.